Greetings, everyone. This is Mark Herzog from BIC Magazine. Welcome to today's webinar on the fear of change in LDAR, new and emerging technologies for leak detection and repair. I will introduce our speakers in a moment, but first, just a few quick pointers regarding your desktop console. There is a Q&A box to the right of the slides where you can text in questions anytime during the presentation. There are several useful PDFs in what we call related content. If you click on the blue paperclip icon, you'll see presentation slides, links to, as I said, PDFs, some additional videos. The speaker bio widget has links to the speaker's email addresses and LinkedIn profiles. The media player window will actually expand when a video is played. You can adjust the size of any of the windows at any time. If you're watching on a mobile device, you just tap the screen to see the widgets. I'd like to thank our sponsor, Montrose Environmental. With more than 1,700 employees in 70 locations, Montrose focuses on environmental solutions with an integrated approach to design, engineering, and operations. They apply the latest technologies to solve difficult environmental challenges today and prepare for what's coming tomorrow. From lab services to stack testing to regulatory compliance, Montrose helps clients blaze new trails. Please visit them at montrose-env.com. Today's presenters from Montrose are Terence Trefiak, Vice President for LDAR Canada, and Tanya Jackson, Vice President for LDAR USA. I'd like to hand the mic over to Tanya.
Thank you so much, Mark. So we're going to get started today, and this is going to be the third webinar that we've done in our four-part Fear of Change series. With new and emerging LDAR technologies making the waves in the industry, it can be very hard to discern which ones are most likely to be beneficial to your efforts to detect leaks sooner and which ones are more likely to be more trouble than they're worth. So if you find yourself interested in the potential benefits that some of these technologies can provide you, but you're hesitant to try them out due to the perceived risk, then you're in the right place definitely today. You might very well be letting a fear of the unknown hold you back from technologies that can improve the efficiency and ultimately lower the cost of your LDAR program, which we know is a big concern. Today, we're going to examine some common fears often associated with a reluctance to try new and emerging LDAR technologies. We're also going to look at some of the LDAR technologies on the market and reveal which ones should be considered implementing. Lastly, we're going to provide the steps you can take to utilize these technologies in your LDAR efforts while reducing costs, increasing efficiency, and minimizing the risk of noncompliance. Now, adopting and using an LDAR technology, whether it's new to you or truly something cutting edge and innovative, can be scary, and I get that. That's because change is scary, and we've all gone through a lot of change recently, especially with COVID. So we're definitely in that place where we're dealing with a lot of uncertainty and we want to feel safe. And the reality is human beings are hardwired to fear uncertainty. Case in point. Do any of these statements sound familiar? Take a minute and read them yourselves, but maybe you've heard them from a colleague, or maybe you've said some of these things yourself. And if so, there's some bad news for you. You're selling yourself short on an LDAR program. Statements like the ones you see here stem from psychologists call fear-based decision-making. The hard truth is that we're not the rational creatures that we like to think we are. Research has shown that our cognitive biases, such as fears and personal experiences, can short-circuit our attempt at logical decision-making. For example, we might overestimate the risk of being bitten by a snake or a dog in the park when we were a kid, which becomes a traumatic encounter. Our negative experience and that emotional response elicits within us interferes with our logical process of determining risk. That's an example of a cognitive bias. Another example would be a fear of failure. which is something we covered in our Part 2 Fear of Change series. And specifically, nothing affects our risk quite like fear. Research has shown us that negative emotions like fear tend to result in a greater perception of risk and a lower assessment of benefits. In other words, we make it easy for ourselves to stick with the status quo. When faced with the prospect of making a change or staying the course, our fear of the unknown encourages us to perceive greater risk in trying something new and to minimize the potential benefits. And when we listen to this fear, we stay put. Let's say you do recognize that a change needs to take place in your LDAR program. You want to make it more efficient, but then again, as you mull things over, your LDAR program is compliant. Plus, your Method 21 costs are acceptable, so you're on the fence. You might do a little digging into the alternative work practice, but fears of the red tape, non-compliance, a fear of failure fills your head. You ultimately decide that your LDAR program is good enough and you call it a day. But as comforting as thoughts of compliance and low cost may be, comfort can turn into complacency. And should you find yourself complacent, sticking adamantly to the tried and true technologies of yesterday, it can come up costing you much more in the long run. New and emerging LDAR technologies hold great potential in helping you to detect leaks sooner and more efficiently than standard Method 21. Many innovative LDAR technologies have been around for years, but they've only recently advanced to the point of industry proliferation. Now I'm going to put my psychology hat back on for a minute. Most of you have at least have a high level of awareness of the benefits that LDAR technologies outside of traditional Method 21 can provide. So let's say that you're willing to ignore your irrational fears and press onward with making a change, be it with optical gas imaging or another LDAR technology. Well, unfortunately, you can't turn your negative emotions off with the flip of a switch. We just don't work that way. They'll be with you every step of the way, from the time you make the decision to implement a new LDAR technology to the time you're up and running. In fact, when any of us go through an uncomfortable change, there's a 4-stage process that looks like this: shock and disorientation, anger and other emotional responses, coming to terms with the new normal, acceptance and moving forward. If you've attended our previous webinars in this series, these 4 stages look familiar. We're using these as our framework to chart the emotional journey a Montrose client goes through when stepping outside their comfort zone to enact that positive change to their LDAR program. Now, our goal for you is to get you through those uncomfortable stages of 1 and 2, and ultimately put your mind at ease sooner in stages 3 and 4. To do that, we're going to alleviate your fears by bringing certainty to the idea of using new and emerging technologies. So first, Terrence is going to take the stage and address the concerns we see from clients when they start exploring alternative technologies. Terrence, I'm going to pass it over to you.
Okay, thanks, Tanya. Yeah, I'm going to go through the different technologies and talk about some of these roadblocks that a lot of people perceive that will prevent them from, exploring these options. Some of the common ones, or one of the most common ones, is compliance and fear that their, state or federal regulator will not approve of this technology. And that's a legitimate concern, but a lot of times we can show our clients that it's an unfounded concern, that a lot of times there's other companies already using these technologies for similar regulations. Other concerns are definitely about cost. Cost will go up with changing a program or doing something different, or it will require more involvement from the on-site operations or maintenance crew. Some concerns we get back are you're going to find too many leaks, you're going to find not enough leaks, or you can't measure the leaks, whether it's OGI or a different technology. There's the perception that you can't accurately measure those leaks. So I'm going to kind of address a lot of these concerns as I go through the presentation. But essentially, all of these concerns we've proven to be false. We've implemented very successful programs with these new technologies. So before I get into the individual technologies, I want to talk a bit about how we kind of put the different technologies in buckets, we talk about kind of the 3 levels of LDAR technology. There's micro detection, which is an instrument that you use, whether it's a Method 21 instrument or an OGI camera, to find the exact leak source. So it's pinpointing the valve packing on this particular valve. When we talk about macro detection, it's more of a full facility screening system where you're scanning large areas and determining areas of elevated emission, or even smaller facilities or parts of the facility with elevated emissions. And then we have the 3rd level, which is program management, which is the database, the software, the hardware that you collect, store, and transmit the LDAR information. And all 3 of these, the micro, the macro, and the program management, work together to create an effective LDAR program. And there's different technologies that can apply to each of these different levels. So some of the common micro technologies, obviously you have optical gas imaging cameras. You have various different PPM measurement devices. Here's a couple listed that we commonly use. Then there's very low tech, which is bubble test or Snoop. Even though it's very low tech, it's still commonly used by a lot of LDAR technicians. Then we have other technologies that actually measure the flow rate of emissions, which is one of them is the backrack high flow sampler, which is a discontinued technology, but there's a number of vendors that are creating version 2 of high flow samplers, which will kind of enable us to really start accurately measuring leaks and vents from different sources. I want to talk a bit about optical gas imaging in detail. Optical gas imaging isn't really a new technology. It's been around for 15 or 16 years. It has changed over those years and become better and more useful, and the technology has progressed, but it's still not used widely throughout industry. It's still, compared to Method 21, especially in the US, it's really a small portion of facilities actually use OGI for full compliance. There's a lot of facilities that'll use it as a supplemental to their Method 21, but very few are using it for full compliance. And again, that goes back to some of these perceived roadblocks that we see. When we compare Method 21 to OGI, there's a lot of benefits that OGI presents. One of the main things is the efficiency. So you're able to scan facilities so much quicker, and then that enables you to increase the frequency of scanning those facilities. So if you're following the alternative work practice in the US, for example, which is the protocol you follow to replace Method 21, certified by the EPA, you increase the frequency of inspection above and beyond what you would normally do with Method 21. So you're going to find leaks faster, and that's where you get the benefit, especially when you find your big leaks faster. And we've been able to show that it's up to a 90% emission reduction when you compare using standard Method 21 to optical gas imaging with alternative work practice. Here's an example in this chart here that shows some of the reductions. This is one specific facility that we looked at, and we were doing alternative work practice in this facility, and we back calculated out to where those emissions, or when those emissions would have been found using a standard Method 21 program, and calculated what those emission rates would have been, and we can show that there's a pretty significant emission reduction when you apply this alternative work practice methodology. One of the concerns with not just with OGI but other technologies other than Method 21 is that you won't get that PPM reading to do your emission calculations and estimate your emissions. And we do collect, for example, when we're doing alternative work practice program and using the camera, we do collect PPM readings using a device, a Method 21 device, when we find the leak with the camera. It's not required by most regulations, but we do that to get the PPM reading because our clients like it. But what we try and promote is that PPM readings and using correlation equations are very inaccurate. And we're trying to push industry to move away from that and actually measure the actual flow rate of emissions using other technologies. And this chart here shows how if you take your PPM readings, 500, 10,000, 100,000, 1 million PPM, if you apply EPA emission factors, this is for oil and gas emission factors, and you get your emission rates on the third column in cubic feet per minute. And then if you compare them to the actual cubic feet per minute rates that we measure, and this is taken from thousands of measurements in our database, you can see that at the low ends, 500 ppm and 10,000 ppm, the rates are about the same. But as soon as you get to higher ppm readings, it diverges significantly. So if you have a 500,000 ppm, the correlation equation is going to give you a 0.02 CFM when it could actually be around 1. So that's a 5,000% difference. And then when you get to even higher emissions, up to 1 million ppm, which most devices would peg out far before that. But even if you could measure that high, you're potentially having hundreds of thousands of percent error. And this is where we try and promote the change from looking at number of leaks, because if you just use the correlation equations, a small leak to a large leak is really not that difference. You're talking one or two magnitudes of order. But if you actually look at the actual emission rates, you're looking at many magnitudes of error, and it's quite significant. So we're trying to promote that change from looking at number of leaks, which is how most LDAR programs are graded, to the actual size of leaks. Because you could have a facility that has 10,000 leaks, and you could have a facility that has 10 leaks, and that facility with 10 leaks could have many thousand times more volume in leak volume than the 10,000 leak facility. So it's definitely a mind change to going beyond just ppm readings. And this is just a visual representation of that. So if we were to use, method 21, all of the leaks would be kind of that first box. They'd all be kind of really small, but we know that leaks vary significantly in very, very significantly in volume. And with a technology like OGI, we can visually see these leaks. We can see if it's small, medium, large, or extremely large, which is something you don't get with method 21. And this is really where you get that emission reduction. If you're using standard method 21 and you have this fire hydrant going off and you're not going to get to it for 6 months, it's going to create a lot of emissions. Whereas if you increase the frequency with OGI or any other technology that increases frequency, you're going to get to that leak much sooner and shut off that hydrant. So the reality is OGI is recognized by the EPA and many state regulators as well. Definitely for state regulations and permit requirements, having an experienced, trusted contractor or consultant help you move through that is beneficial. The cost of AWP is really an efficiency issue. So it's much more efficient. We're able to get the cost down, and we've been able to show a decrease in cost from standard method 21 program because of that high efficiency. It also eliminates ghost leaks, which is identifying the wrong component leaking, and really helps with determining the actual leak source of emission of components. And as I mentioned earlier, you get a massive emission reduction because of that frequency and finding the leaks faster. There's definitely new technologies coming out. I was at the 4C conference last week, and we saw a ton of new technology and new things that we haven't seen before. One was the Spot robot from Boston Dynamics. So they've actually are able to put a OGI camera and a laser methane or laser tunable diode laser system on these robots, and this could be an application where you're sending in a robot to an area that may be inaccessible or unsafe to access with the human. So we're looking at this technology. I think this is going to be growing in the next few years. Now, if we move over to the macro technologies, we've kind of divided the macro technologies into two sections. One is mobile, and one is stationary. So under mobile, we have any kind of aerial survey, whether it's a drone, whether that's a copter drone or fixed wing drone, or fixed wing manned flights, or helicopter manned flights, or satellite detection. Then you have your land surveys, so that's vehicle based, whether it's a truck or some type of off-road vehicle. And then you have your stationary macro detection. So that's installed sensor arrays that provide 27 coverage and have triangulation. So I'll talk about a few of these technologies that we've applied for our clients. One macro technology that we've utilized for methane detection is a vehicle-based system where we utilize the Picaro G2301 methane analyzer, which is a very sensitive methane analyzer that's accurate and can get down to parts per billion measurements of methane. And when you combine that with wind and met data on your vehicle and with software, you can actually develop a triangulation system where you can drive around sites and use the triangulation to find out where on sites you have those emissions, or drive, there's kind of two different applications for this. You can use it on a large site to find high areas of emissions, or you can use it for, say, on, upstream well sites. If you have, hundreds or thousands of well sites, you could drive the vehicle around those well sites and eliminate the ones that have little or no emissions and focus on the ones that have significant emissions. And combine that, so when you did find a site with high emissions, you could jump out with your OGI camera, go and scan that facility, find the leaks, and really reduce the amount of time, so you're not going to those sites with OGI that have no leaks. And this is really what combination of, you have a macro and a micro detection, where you can use them together to decrease cost, but increase efficiency and increase the time, or decrease the time you're going to have between finding those big leaks. One of the important things about this technology is, the car device is very, very sensitive and works well, but kind of the secret sauce is having it linked up to a software system that can use that data with the metadata and triangulate. And that's where you can actually use that technology to triangulate where the emission is coming from. Let me just see, you're going to go to the next slide here. I think this will play the video. Okay, I guess we have music. This video. I don't see that the video is playing, but now I'm frozen out. Okay. Okay, I see the video playing here. Yeah, so this was a video taken with a PCR van, which was looking for VTEX, and the VTEX van is a different sensor than the Picaro device, but this was just an example to show you that the emission levels you get by just driving the vehicle. But when you actually stop and use the triangulation, which is the slide I'm showing now, so for example, you could drive that vehicle around your sites or your facilities. When you do find emission, you can stop and take some readings in different areas and then start doing the triangulation. And the triangulation is really what, again, what makes this technology very useful. And there's third-party triangulation softwares that are out there that pull in sensor data. We also have, Montrose has its own proprietary algorithms that they developed to do triangulation as well. But depending on the application and the technology you're using, there's different triangulation softwares out there. Some other macro technologies is drone detection. This particular one we're showing right now is a laser-based system where you have a laser that detects methane in parts per million meter. And you would have this drone, you would fly it up, the laser would be pointing down to the ground, and you would fly a pattern over the facility, flight path, and it would detect, hundreds or even thousands of points where it would show what the methane is in those streams or in that area. It can help prioritize sites with higher emission levels, and it's quite surprisingly very accurate. When we started using this technology and testing it out, we weren't sure if it was going to be accurate enough or efficient enough to be better than just doing, say, an OGI survey. If you're going to take this drone out to the facility and you have OGI out there, would it actually save any time or money? And we found after doing the testing that it actually was so efficient that it could prioritize and direct the OGI inspection to areas, to those hotspot areas, again, to find those leaks faster. Here's an example of a drone survey. So it was a compressor station with about 4 compressors. The bottom left picture shows a flight plan that was developed for that facility. And once it flies the flight plan, it then has a bunch of data that you have to filter through and analyze. And then you can pull out the top right picture, pulls out the points of elevated emissions. And then you can use all those emission points to then put into a mapping system to actually show the hotspots. and show where those hotspots are and where to focus your emission your micro detection. So the application for this, we think it's very applicable to large facilities where you want to focus down your inspections. For example, we do a term of work practice program at 2 of the largest LNG facilities in the U.S. And even with OGI, which is very efficient, it still takes up to 6 weeks to get through the entire facility with OGI. In those in between times, you could be sending out a drone to identify those areas of hotspots and prioritize your assessment, your OGI survey to hit those hotspots first. So again, you're reducing the time it takes to find those large emissions. Other application for drones would be, again, if you have a number of small facilities over a large area, you could use that drone to, again, similar to the vehicle-based, prioritize your inspections on those facilities that are having significant emissions. On this particular example that I showed, the drone survey took about 14 minutes, and versus the OGI survey that would take about 5 hours. And it really would help you to eliminate areas that you had no emissions, so you're not wasting time on OGI that areas have no emissions. So it again really helps to narrow the focus of those of an OGI survey. We feel that this technology is really going to help us with our clients. They're using OGI, but also in other areas like pipeline surveys, where you can survey long areas of pipeline with a drone to find any potential leak sources for underground emissions, and another really potential good source is abandoned wells. We're looking at projects where you have abandoned wells, even in populated areas that have been, where you have houses and businesses over top of those wells. You can use a drone to basically survey that area and get and areas, especially where you have hard areas to access. Sensors array and triangulation. So this is the stationary macro detection, where basically you have sensors put out around a facility, and those sensors, whether they're picking up methane or VOC or any other component you're interested in, and they provide 24/7 coverage of the site. So they're going to alarm if there's an elevated detection above the baseline, and you get that early detection of large leak sources. If you have triangulation set up with that, you can get you can identify the areas of your facility that are intentional emissions, that your rod packing vents or tank vents where there's emissions, and then if you get a new emission in an area that is not intentional, then you can identify that as a leak and then basically direct an inspection. And this is really ideal for large sites, but it can also work for smaller sites. But really, this creates an early detection or reactionary program as opposed to just a random survey. So let's say you have to go to that site, quarterly to do your survey. A large leak might have happened the day that your LDAR technician left that site. And if you base it on the actual sensor data, you can trigger an inspection as opposed to just waiting for the next inspection. And we think that this is really going to be quite popular, especially with the focus on methane emission reduction for greenhouse gas. This is really the one the one technology that gives you the earliest detection and the full coverage of your facility. And what's made this a lot more popular recently is the cost of various sensors has come down significantly. The technology has advanced. The cost of VOC sensors in particular has come down quite a bit. And the systems that we use, for example, you can interchange any type of sensor you want and link it up to the software and the algorithms, which again is that kind of secret sauce that makes the whole package work. But a lot of clients have kind of shied away from this because of the high cost or perceived high cost. But the cost of these sensors has come down, the cost of the software and the technology behind the software has come down to make it much more affordable. And again, this is what we think is really is going to be the key for significant emission reduction on large sites. But we've also applied this technology on small sites, on single well sites, where you have maybe hundreds of sensors out there on hundreds of well sites. So it's very flexible, and again, something that we think is going to be the future of LDAR. One of the other benefits is a lot of large facilities require fence line monitoring, and a lot of them are passive fence line monitoring. You could use a system like this to elevated to an active system that would cover your fence line monitoring, but then also with the triangulation would benefit your LDAR program. So there's a lot of benefits other than just LDAR when you look at these sensor systems. Here's another video. Let's see if I can play it here. Not sure if it's playing. Okay, here we go. It's quite a long video. I'm not sure how much we'll play, but this is an example of a sensor array that we had. This was for a tank farm at a refinery. And this was, they just had some sensors along one area where they were worried about transmission of emissions. And I don't know if I can get the video to go ahead enough, but basically when you get a hit on one sensor and starts collecting data, it immediately starts using the metadata to triangulate where that emission is coming from. And as you hit more sensors, collect that emission data, it gets more and more accurate as more sensors hit. And then you start to round down where that emission is coming from and get more and more accurate. And a lot of these systems now are kind of self-learning. So they identify, where you have those intentional emissions, and if there's an emission in a new area, you can alarm it, or set it so it automatically alarms if there's new emissions in those areas where you don't expect to have any intentional emissions. And they're again, the systems have advanced quite significantly in the past few years, and we think it's going to be the future of LDAR. Okay. Okay. Can't really see what slide I'm on, Tanya. Can you see?
Oh yeah, it's the strategic approaches. So I can cover this for you. So the next slide that we're talking about is strategic approaches. So while we've talked about all these different technologies that are out in the industry, there's also various ways that you can start to focus on preventing the emissions as opposed to just reacting and finding them. So using a best available control technologies, replacement of current parts using low emission or no emission components. API has identified API 622, 624, and 641 are all low emission, no emission standards that you can follow when you're purchasing your different components. I mean, they're coming out with new ones all the time. So it's a really great place to focus on new technologies of the replacement of your new parts when you're making your repairs. So another great strategy is to use preventative maintenance schedules. So we schedule all of these inspections. So why not do preventative maintenance on the areas that you've identified from your leak histories that are frequent leakers or repeating leakers. And that way you can get ahead of the leak schedules, preventing them from leaking in the first place. We can also link your LDAR inventory to these maintenance specifications that you have. So one of the things that the manufacturers of parts have talked about is that the format in which people are servicing these components is not to their manufacturer specifications for that particular component. So if we can link those details within your inventory so that when a request for repair or a work order goes out from the LDAR team to the maintenance team, they already have the maintenance specifications already documented for that component right with the work order. And the final piece is utilizing the regulatory consulting analysis. So I think this is a big part that people leave out, is reviewing that from an analysis perspective on a whole. What is your facility doing, and getting that bigger perspective of units that have more issues than other areas, or very specific components that are having more issues. So doing that review in a large scale with a regulatory consulting will provide that big picture for you.
Great, thank you. You didn't talk a bit about LDAR software and how it helps and can help clients manage their programs. Target Track is the Android application that our technicians use to collect field data. We also have clients that use this app when they have in-house programs, or they're doing their own LDAR programs. And this basically is a effective system that you can collect the LDAR data on site, whether it's Method 21, OGI, or any other kind of technology where you're finding leaks, this technology can be used to collect that data, and then immediately communicate that data to a cloud-based system where it's accessible to all the stakeholders for that LDAR program. One of the common things that we've seen with LDAR software in the past is it's usually just a software that the contractor uses, the LDAR contractor uses on site, and they create reports and then provide a report to the client. But really, the advancement in LDAR softwares is made it so that clients and stakeholders can use that software to actually increase in the efficiency and the compliance of their program. Our program Target Online is basically an interface that our clients use to log in and manage their LDAR program. They can, see the recent surveys that have been done. They can calculate how many emissions or what the dollar value of the emissions that they're saving. They can manage their leak detection or their repair program all from one space. And a lot of the benefits of this comes from that cloud-based system where you have immediate communication. When there's a new leak in the field and it's synced up, you can have it so that it immediately contacts the maintenance personnel to notify them that there's a leak that's happened. And again, that goes to getting those leaks repaired faster. And that communication between the LDAR personnel, whether it's in-house or a contractor, and the people, the maintenance crew or the operators that are responsible for the repairs, that's usually a weak link. And then another weak link is actually recording those repairs and getting those operator and maintenance personnel to record and confirm those repairs and get that back in the system for compliance reporting. That's really what we see as the weak link in most systems, and that can be solved by getting a software that can be used effectively by all stakeholders. Again, with the benefits of using systems like this is communicating the appropriate data. So not just having a binder that shows you where the leaks are with handwritten notes. It's sending a picture or a video exactly what's leaking, so that maintenance personnel can make decisions before it even goes to the field to know if he needs to take particular tools or equipment and make a decision how he's going to make that repair and give them that information. And really, we found that this having an effective system that can communicate that data makes a massive difference in the success of an LDAR program. One thing that we've also found that is been very beneficial for our clients is automatic data communication between an LDAR software and external third-party softwares, particularly work order software. So a lot of our clients will use IBM Maximo or SAP or another third-party software to manage their work orders for their maintenance. And we've developed a system that our database can present the data through an API, and the data can automatically, so when a leak is detected, it can automatically be sent through to the work order system. A work order can be automatically created, and the maintenance personnel follow the normal work order procedures. When that work order is closed out, it can then communicate the data back into the LDAR database and close out that leak. And this really automates a very manual and complicated system into something that can work directly with the existing system, with the contract or with the existing client's work order system. And this is what we found has been massive time saving and created a much more compliance based system as opposed to the more manual communication system. I'll hand it back over to Tanya.
Thanks, Terrence. So at this point, we want to highlight the fact that we have all these great technologies, and you can use them not only by themselves or in conjunction with Method 21 or another technology. They're best utilized when you think of these technologies as your toolbox and working with an expert that can use these different tools in the right situations. Now, sometimes our clients are enacting a change to their existing LDAR program because they're proactively seeking out the new efficiency. They want to find something better. Other times, however, you're going to be undergoing a change because either regulators or maybe even your corporate department is making a change that's really forcing your hand. And there's nothing worse than feeling forced to update your program when you feel like you have a great program. It's good enough. And when we feel forced to do something, it's easy for us to become angry and maybe even ticked off, right? But anger can blind us to the benefits of change. We all know that the US government is putting a bigger emphasis on curbing greenhouse gas emissions in its efforts to combat global climate change. This means you need an efficient, cost-effective method for detecting leaks over large areas. Well, with a technology like the portable methane or the spot dog or drones, you can ensure compliance to the increased regulations of greenhouse gas emissions. You can detect smaller leaks that are otherwise accumulated to large sums of lost product over time, and you can improve the overall safety by reducing methane emission levels. The takeaway here is that even when you feel like a change is mandated, there are still benefits to be had. Sometimes our only recourse is to make the best out of the situation. Once you come to terms with the fact that change must happen, regardless of whether it's because of a mandate or issue with costs and efficiencies, the sooner you can embrace the right LDAR technology and come to terms with the new normal and get in those stages 3 and 4, the reaction to change will be more positive. Here are some of the key steps that you can take to overcome the fear of change as it pertains to embracing new and emerging LDAR technologies. First and foremost, understand that the status quo leads to what I call costly complacency, a false sense of security that ends up costing you more in the long run due to Method 21 inefficiencies. Also recognize that this sense of complacency stems from fear-based decision-making, the comfort zone, which makes you feel safe, so we often overestimate the risk and underestimate the benefits of the change. Lastly, and perhaps the most practical, once you're ready to embrace a new LDAR technology, it's what you see on the third bullet. Partner with someone who can help you achieve the benefits of those new technologies. Now, we started this with talking about these statements that maybe you've heard from a colleague before. So let's revisit these statements and see how we can address those to make the fear seem less. Our LDAR program is compliant, so there's no need to fix what's not broken. Embracing a technology allows for an insurmountable amount of saving that reduces not only risk, but costs and improves your ability to manage the situation. There's too much red tape involved with getting new technology cleared with regulators. Working with providers that have the experience to educate regulators and a transition plan to make that transition easier. The upfront costs of these new technologies are a non-starter. It'll take forever to see a return on our investment. Allow your provider to take on those upfront costs and implement the cost savings immediately to you with your program, your inefficiencies with technology. I'd like to thank you both. I'd like to thank everybody here for attending today, and we'll wrap up and just hope that you've taken away some knowledge on new technologies that are out there and hopefully alleviated some of your fears of taking that next step to implement them. So at this time, we'll be taking some questions. So feel free to submit them through the Q&A dialog at the bottom, and I will read through those and see which ones we have here. So we have a question, would you share the presentation document with attendees? The presentation will be shared after, and I believe there's an area to download the slides as well. And this is being recorded, so it will be available online afterwards as well if you have a colleague that wasn't able to attend or you wanted to share the information with your superiors. Okay, here's a great question. So I've been away from LDAR for a while, but is EPA finally on board with using OGI in place of Method 21, or does it take administrative approval from the EPA to use it in lieu of Method 21? Terrence, you want to go ahead and take that one on the approval process?
By following the alternative work practice, which is an EPA document, if you follow that work practice, you're basically in compliance with the federal regulations. So you don't actually need approval from the EPA to start alternative work practice. If your facility falls under the codes or the regulations that are listed in the alternative work practice, which covers almost all LDAR in the U.S., then you can use alternative work practice. Again, you have to make sure that the camera you're using can detect the streams that you're interested in. but there's no approval process for the federal requirement. Depending on which state you're in, some states have alternative work practice and optical gas imaging written right into the regulations. Some states don't. Some states refer back to the EPA requirement, which is then makes it applicable or compliant. And then depending on the permit you have or the state you're in, you may have to get approval from the state. For example, when we did the approval for Freeport LNG in Freeport, Texas, we had to go to the TCEQ, meet with them, and kind of show them, what we were planning to do at that site and how we're going to follow the alternative work practice. And we wrote up a document that showed what we were going to do and basically the protocol we're going to follow. They came back and added a couple minor additions to what their standard alternative work practice was, and they approved it. It was really quite an easy process. And when we're all said and done, both our client and the operators view that program as an advanced or enhanced system compared to Method 21, again, because of that emission reduction. So from the view of the regulators, it's actually looked at as going beyond, above and beyond the normal regulation.
Okay, our next question. How do you know the emissions when using the alternative work practice OGI monitoring method?
Yeah, I assume that's asking about emission quantification. So again, with OGI, if you can see with the camera, it's a leak. Whereas a standard Method 21, you have a ppm, like you might have a 500 ppm leak definition or 10,000. But what we do in all of our alternative work practice programs, which is not required, is when we find a leak with optical gas imaging, we then measure it with a ppm detector to see what the ppm reading is. Again, so we have that data for the emission calculation. But the other thing we also do is actually measure those emissions with some of the technologies like high flow sampler to get the actual emission rate, because we know that using the correlation equations can be, as I mentioned earlier in the presentation, can be very inaccurate. So having the ppm is okay, but having the actual measurement is more valuable. And even having the video of the leak and being able to estimate it with OGI is much more effective than using the ppm readings. Now that's not usable for regulations when you have to report the emissions, but having the direct measurement and the ppm readings can be done when doing OGI.
Our next question, which of these technologies can be used to detect leaks on natural gas gathering lines, and which are the most sensitive or the best for that purpose?
Right. I assume this is for underground gas lines, buried lines. Two things we recommend for that. One is drones. The laser-based drone system is very accurate. You can cover a large area. The only limitation for drones is you have to, with a lot of the requirements, you have to be in sight of the drone. So you can only get a couple miles out, and then you're going to lose sight of the drone if it goes over the horizon. So you got to, focus your survey so that you have that limitation. Still is very possible to do, and can be even, depending on, especially where the pipeline is and what kind of terrain, it can be much more effective than a vehicle-based. And the vehicle-based is the other one that we've done before, is using a system like the Picaro device or a Sensit PMD, which are Sensit PMD is very sensitive. The Picaro device is extremely sensitive. And you can use those devices to basically go along the pipeline, whether it's with a vehicle or a quad or an ATV, and pick up those emissions. Again, usually we use those and you can use that together. So you may have a drone-based system where you're identifying where the hotspots are. Then you can go in with like an OGI camera or a handheld detector to those hotspots and try and pinpoint the area. One of the problems with underground leaks is, if it's a very large leak coming out in one area, you'll see it with the camera. If it's a small leak that's diffusing over a wide area, it may be too diffused to see with the camera. So that's why, the drone system or a vehicle-based system will really help you find out where those hotspots are. But again, it's using those technologies in conjunction. I don't think any one technology is the winner for any particular site, but it's evaluating the type of facility you're looking at and then coming up with a combination of technologies that'll work for that facility.
I think you just answered the next question. Do you think that a single emerging technology will be the future of LDAR?
Yeah, I think the future of LDAR is going to be combining technologies, combining effective macro and effective micro technologies, and an effective software system to combine all that, and that's going to really be the future.
And we got 2 more questions here, so if anyone else, feel free to submit. We still have a little bit of time left. Let's see here. Can you address the near-term future use of drones and other airborne vehicles, as well as satellites, to both identify and accurately quantify?
Yeah, I mean, there's clients of ours right now, they're using drones for, or they're using our drones for detection, and there's other companies that are providing drones, whether it's, there's different drones out there. There's drones that you can use, put an OGI camera in a drone, or you can use a laser-based system, or you can even combine both of those into one. So they're, depending on the application, they're currently being used. I think that the laser-based system is, that's the way we decided to focus on. We think that's the most effective. With putting an OGI camera in a drone, you still need someone to be actively looking through that camera and seeing the emissions. It doesn't, the OGI camera doesn't alarm when you have an emission. You have to visually see it. So that's one limitation when using OGI on a drone. But combining both OGI and a laser-based system on a drone can be very effective, because then you can identify the hotspot with the laser, and then focus in with the camera, and then really try and visualize that emission.
Yeah, I think so. How are you addressing real-time notification?
Well, there's a few different ways. I mean, for example, in our Target Online system, if a leak is detected, you can immediately be put onto the online system that our clients have access to, and it can notify them via an email saying that, you have 6 new leaks in your area, or they can have actual access to the application where it's on their phone, where it can notify them that there's new leaks in their area. And then the third way, which we've seen really good success, is having a direct link between our database software, or our database, and a work order system, so that it automatically sends the leak, creates the work order automatically, and they get notified because they get a new work order. That's what we think is been the most successful in really communicating those leaks in the most effective manner.
I think you could also probably include the sensor arrays in there, right? Because that's a real-time notification as well.
Yeah, sorry, I was thinking more of the monitoring, but yeah, definitely, Tanya, for the sensor arrays. I mean, you have a system that is constantly evaluating your facility, and you get notification, via the software that says you have an emission in this area or multiple emissions. So that's really, again, that 24/7 coverage is immediate notification or identification that you have something going on your site.
Great. Are there handheld monitors out there capable of measuring EDC in ppb levels?
I'm not sure what EDC is.
I'm not sure either. Maybe whoever submitted that question.
We can forward that question onto our emerging technologies group, and they can get back and answer that question.
That's a good one. What do you see as the future for gas utility LDAR in urban and suburban areas?
Well, I think, again, it's probably a combination. I think that installed sensors are going to be, having that 24/7 coverage, and Montrose is already working on projects like that are combine the community and the client to provide an array of sensors that can give you that sense of security and that early detection. Yeah, a combination of technologies, like, for example, we're using drones in populated areas to scan abandoned wells and underground pipelines, where we don't need to get into someone's backyard to walk the route. We can actually fly a drone over top, identify those hotspots, and instead of having to walk through, a neighborhood that might take you a month to walk through, you can do it in a couple of days, identify the hotspots, and get access to those areas that there's potential issues.
Great, and I think we have one last question here. This is more related to our fear of change in LDAR, but they were asking the related content for the other recordings for the fear of change. Can we use the same video link? So it would probably be best to go onto the Montrose website because they were hosted by different groups. So if you go on the Montrose website and go to the LDAR area, you'll see the other recordings for the Fear of Change series. And there will be another one in November that's going to be looking more at the regulations and how they're changing and evolving. And that will be more of a panel setting where we'll have a couple of industry experts as well as some Montrose experts on the panel. Great. Mark, I'll hand it back over to you and we'll wrap up.
Very good. Thanks, Tanya, and thank you, Terrence, very much for the educational presentation here. I do want to remind everyone that it will be available in the recorded version in about 2 hours. Just go to bicwebinars.com, or you can use the same link that you used today. If you'd like to share it with colleagues, ask them to go to bicwebinars.com, select the webinar, and register on their own. The related content has a number of assets that could be valuable, and you can connect with the speakers. You can see their email addresses on the screen right now, but you can also look under the speaker bio box there to get to their emails and to their LinkedIn profiles. Please bookmark bicmagazine.com for daily access to articles, videos, etc., on current news, trends, industry expansions, and technical knowledge you need to stay ahead in your business. And thanks again to Montrose. Please visit them at montrose-env.com. Thanks, and have a safe day.